Hello and welcome to the Online College of Coding video tutorial series. This is video 3 on the series of getting started with Unity. In this video we're going to be looking at creating our first C# script in Unity using its editor MonoDevelop. Before starting this video, it's recommended that you've watched the earlier introductory Unity videos. So let's get started. So it's time to start creating our first C# script. And to do that, we're going to use a project that we created earlier in video 3 and continue working from there. Before we move on, let's have a look at the project view down the bottom, where we're going to look at how we can keep our project ordered and logical. And so what we're going to do is create 3 folders here underneath this assets folder, and we're going to use 2 of those folders in this video. To create new folders, we right click and go create folder. The first folder we want to create is called scripts, and that's where we're going to be saving the script that we create in this video. Now let's go ahead and create a second folder called scenes. And a third folder called prefabs. And as we've already got a scene that we've created, let's move that scene into our new folder called Scenes by clicking and holding here and dragging it into our Scenes folder. And so now we can create our C# script. We do that by selecting our folder and then over the right hand side here, right clicking, clicking on Create and then C# script. Now Unity can use 2 main programming languages. They are C# and JavaScript. They're both very similar in this style, but we're going to be focusing on using C# for these Online College of Coding video tutorials. Now there's 3 important things to remember when creating a new script. The first thing is that as soon as you create it, you need to give it a name. The second thing is that it's good practice to name your script with a capital letter for each of the words within its name. And the third thing is that when you give it a name, it needs to refer to the primary function of what the script will be doing within the game that you're creating. In our example, we're going to be using this script to make the objects within our game bounce up and down, so we're going to be calling it bounce. Once you've created your script, double click on it, and this will open a program called MonoDevelop, which is built into Unity. MonoDevelop is the editor that we use within Unity to create and edit our scripts. Over on the left hand side is our folder hierarchy for our project. It's just like Unity's project browser, and here you can use it to open scripts without having to go back to Unity. On the right hand side is where your script is open, ready for us to edit. Notice up the top here, after the name of our script is the .cs file extension. This stands for the fact that this is a C# script, just the same way that a DOC file tells us that it is a Microsoft Word document. The numbers down the left hand side here are useful for navigating through our file if our script gets really large. It also helps when Unity tells you about errors. You can use the line numbers to help you find your error. The script that we've created starts out with a whole lot of programming code already in it. Every time we create a new script, it will look exactly like this, just with a different name. Notice that the name of our script is also reflected just here, and that's very important. If these 2 don't match, our script isn't going to work properly. Within our script, the different colors to the text mean different things. All of the light blue or aqua words are special control words that the programming language has a particular use for. They're words like public or using. And they're like words in our English language like help or thank you, that we understand explicitly exactly what those words mean, and they only have one purpose. All of the dark blue words are used to describe things. They're like adjectives. So bounce or void are describing something within this script. All of the black words are naming words. They're words like house or tree or nouns within our English language. These grey words here that are started with these double forward slashes indicate that these are comments within our script. Comments don't serve any purpose other than to describe what's actually happening in the rest of our script. If we had some orange within our script here, that would be indicating that these are values, usually referred to as variables. And any words that show in red are where the program thinks that there's a problem with our script. They are an error, which is why they show in red. And next we have the punctuation that exists within the code. Firstly, we have the semicolon. It works like a full stop in the English language. It's used to separate code statements, the same way as a full stop separates individual sentences. And next we have the parentheses. They work like the start and end of a paragraph, but in code they show the start and the end of a specific chunk of code called a function. You must always have the same number of open parentheses as you do close parentheses. And if we modify our code slightly by moving this parentheses down here, you can see its corresponding closed one is here, and here within this one, the corresponding open and close, and corresponding open and close. So these ones here are sort of saying that this is like the whole big story, open and close, and these ones are saying, well, this is at one paragraph, and this is another paragraph representing this function and this function. So let's drill down a little bit further into our code and have a look at four main sections within it. Starting with the first two lines of code, which have the special using control word at the beginning, they are telling this C# script that they can use the Unity engine and system collections code libraries that are built within Unity to access built-in functions within the Unity game engine. The next key section to look at is line 4. Public class bounce is telling the C# script to create a public class called bounce. By it being a public class, that is making this class accessible to other game objects within the game that we are going to be creating. A class is like a blueprint or a template, and this template, called bounce, is based off another template called monobehavior. This means that bounce is a child to monobehavior. Just like inheritance that works in the Unity hierarchy, any changes to monobehavior will also be reflected in bounce. Every script in Unity is a child to monobehavior. And the final two sections within our code are these two functions or methods. This one's called start and this one's called update. A function is given a name so that each section of code can be called from elsewhere within the script, or sometimes even from a completely different script altogether. And before the name of the function we have this special describing word or return type. This is the type of value that will be calculated by the segment of code within the function. Void means nothing, so we know that this section of code will only be following instructions and not doing any calculations. This start function is only run when the game first starts or initializes, whereas the update function is called once every frame within the game. So let's start adding our own code to this script. On line 6, we're going to declare a public float variable called jump power, and we're going to assign it a value of 3.5. So public is our special control word which makes this variable accessible anywhere within our game. Float is our special describing word which describes what type of variable this is. In this case it's a floating point value. Jump power is the name of our variable. A variable must start with a letter and can't have any spaces. And 3.5f is the actual value that we've assigned to our variable, and it shows up in orange. The F indicates that it's a floating point value, And very importantly, we need to finish our line of code with a semicolon. And now we're going to add a few lines of code to our void update function. These lines of code are going to make it so that when we press spacebar, all of the game objects that have got this bounce script applied to them are going to jump, with the game updating or rerunning this function once every frame. Now you can either open your accompanying tutorial document and copy and paste this line of code from it, or you can press pause now in the video and start typing these lines of code yourself using the built-in IntelliSense functions to help you get the syntax and grammar correct. And once you're happy with your script and that there's no errors within it, we need to save our script and return to Unity and apply that script to each of the game objects that we want to have affected by that script. We can do it two ways. We can drag our newly created script onto the objects within the hierarchy, or we can drag it onto the objects in the scene. You can check to see that your bounce script has been applied to all of your game objects by looking at the details in the inspector. So if I select my game object and look over here in the inspector, there's my script. And here, again, my script has been added as a component of that game object. Once you're satisfied that everything is ready, if you click on play in the toolbar, your game can be tested, and if you press spacebar, you can see that your objects will bounce around. And that concludes video 3 of our Getting Started with Unity 3D series. Congratulations on creating your first C# script in Unity. When you're ready, you can move on to video 4, which is the last in this series, where we will look at some of the more advanced C# programming concepts that will be used in the Online College of Coding tutorials.